Apparently we're going to do question number 8 from the homework. And so let's take just a brief second to draw out question number 8 from the homework. And I don't know why I like drawing these. Something about when it's all done and you guys people actually listen to these videos, which I think is hilarious because I find them to be just mind-numbingly dull. So you guys who listen to them, yay, I'm glad. That's the only reason I do it. But to be honest with you, I kind of should have just turned this iPad back in and not kept it. Because I ended up paying for it, but I think the videos are kind of lame. So, how many of you listen to the videos at all? Keep your hands up if you think they're kind of lame. See? They're lame. Even all of you think they're lame. So why do you watch them? So they help even if they're lame? What would make them more exciting? Should I be more animated in my talking? What? I didn't hear what you said. Explosions always help.
Every few minutes, throw in like a physics joke.
A physics joke.
Jasmine would just watch it for entertainment.
You know what I really should do? How many of you watch these on a computer? How many watch these with headphones?
Should flash their ears.
Every once in a while. So, for all of you who are a big disappointment, let's put all the labels there. We are told that there is a coefficient of static friction here. That's mu(s). And if I recall correctly from my physics from long, long ago, static friction is less than or equal to mu(s) times the normal force. Any questions about that? Well, as I look at this, I'm going to take a look at a free body diagram for 3 different objects. I think that's probably in the cards here. There is a shorter method to do this problem than what I'm going to show you. And I might throw part of it out there in a minute. But let's just look at the basics. How would you solve this? I would start by probably saying this one is the easiest to analyze. mh times g and t, only forces acting on it. I'm going to say that this is the positive direction. Question about that? All right. The box on the top there. So let's look at its free body diagram. Actually, I'll make it easier. I'm going to need more space than that, so hear me out. I'm going to do little m stuff right here. So it's experiencing a force of tension in this direction. It's experiencing a frictional force in this direction, and it has to be the static frictional force. It's experiencing a normal force in this direction. And it's experiencing weight downwards. I think the tension's got to be greater than the frictional static force. Any questions about this? Alrighty. The box that's actually resting on a table is experiencing a group of its own forces. It's experiencing a normal force downwards that's equivalent to the normal force upwards on the smaller box. It's got its weight downwards. It's got a normal force from the table upwards. And by Newton's third law, it's experiencing a frictional force this direction that is equivalent to the frictional force experienced by the top box in the opposite direction. It is this frictional force that causes the bottom box to accelerate. Without it, there'd be no acceleration of the bottom box. questions? That's it. Yeah.
For when we set this, the box that's connected to the rope on the bigger box, and you set that equal to the acceleration, would it be m plus ma?
Based on my free body diagrams currently, they are all individual masses. So they're acting only on those masses. You could treat parts of this as a system if you wish. In fact, there's a super shortcut to get to the acceleration if you want. And I'll talk about that here in just a second. But understand that right now, the way we've done this, we've done it all based on individual masses. Now, we are hoping to create the conditions where each of these objects has the same acceleration. Right? That's what we want to have happen. That the entire system accelerates at the same rate. If it doesn't, then we broke the static friction or we cut the cable or something like that. But currently, the way we set this up is we want all of them to have the same net force equals MA, where A is the same for all of them. Now, quick aside, and I'm going to just go to another screen. So getting back to here, let's recognize that I only have to worry about the X direction for the boxes that are on the table. Good so far? You understand what I mean by that? So I'm thinking net force equals MA, so tension minus friction equals MA. Questions? Alrighty. Actually, I was wrong. Because friction's based on a normal force, I should probably look at the Y direction for this box too, which is going to be 0, which tells me that the normal force that causes friction is equal to mg. I'm probably going to need that. All right. Now, over here, net force is going to equal capital MA, which is going to be the static frictional force equals capital MA. And last, MHG minus tension equals MHA. Now, I've done most of the physics, but I have like 1, 2, 3, 4, 5 equations and a just large group of unknowns. I have to whittle this down to, I think, mu. I think they want an expression for mu. Whew. That's a lot of substitution I'm about to do. 5 relationships. And if I want to really do it right, my final substitution should be into here. So I get my dependence with the inequality. That would be nice. Now, if you don't want to do it that way, set the inequality to equal sign and understand you are, by definition, looking for the max. But if you want to end with a nice little inequality so you can prove to yourself that you're dealing with the max, then do your final substitutions into this equation and leave the inequality preserved. Now, there's quite a bit of crap here to put together. Yes, sir?
You don't have to solve for the mass hung.
The mass hung. Okay, only. Okay, that's still going to be in terms of mu then. All right, so I can have mu in my answer?
Yeah.
All right, magically craptastic. Let's go do it. Mass hung. Well, let's start by, I can do a couple of things. First, and this is where I'm going to start, I'm going to recognize that static frictional force is less than or equal to mu s mg. Good so far? Let's see, I could do this substitution right now. But I don't have the acceleration. Right? So if I had not solved for the acceleration in the prior portion of the problem, I wouldn't be able to get an answer because I'd have A in my answer. Meaning, I could do that substitution. I will get big M times A is less than or equal to mu s mg. Now, I couldn't solve this because I don't have mass hung in here yet. Probably by figuring out the acceleration, I can get the mass hung in there. And I think the acceleration is going to come from, need another color, this substitution. Damn, this is a lot, isn't it? It would have been so much easier just to use the acceleration from the prior page, because I'd be one step and done. But if I didn't know how to do that, I'd be stuck doing all this garbage. So let's keep going. Let's see, that's going to be T minus Fs equals Ma, which is going to be MHG minus T equals MHA. I can add those two equations up, can I? Giving me MHG minus Fs equals M plus MHA. That's fun. That was fun. Did you guys like that? I did too. It was terribly, terribly exciting. Now, hey, just between you and me, I can substitute that again. Right? Which gives me MHG minus MA equals M plus MH times A. Can I move it to the other side? Yeah, holy crap, I can. And do you guys notice what we get when we move it to the other side? I'm kind of out of space. Wow, look at that. That's so fun to look at. It's like what would happen if your physics problem just exploded all over the page. But I'm going to point out that, and help me with this if you don't mind. Over here, I'm going to take this and move it to here, right? And factor out the A. So since by this point you guys have all caught up with me, you know that what I'm going to produce is MHG equals M plus MH times A. Well, that looks damn familiar. I really think that that's exactly what's on. This is definitely not the easiest way to do that. But at least now I have a way of eliminating A here. Right? Can I do that maybe on the other page where there's less distraction? Thank you. Whoever said no can just side real quick. The net force equals Ma. The unbalanced force is the mass hung. That is the unbalanced force acting on the entire system. It has to be equal to the mass of the system times the acceleration of the system, which means I can immediately tell you what the acceleration of the system is before I do any of this work. That has to be the acceleration of the system. Because the weight hung is the only unbalanced force acting on the system externally, gravity. Tension acts in opposite directions on the small box and the mass hung. Friction acts in opposite directions on the small box and the box on the table. For the system, those are all internal forces. This is the only external force, and the entire system's inertia is accelerated at the same rate. That has to be the acceleration. Now, I could use this to do the problem, or we could show this in the problem. But this is going to be true either way. Page. Oh, it is. Oh, I can't say that on this because it's recording. Yeah. So I'm done with was that M A less than equal to mu S M G. Is that right? So I'm going to get big M over MH plus M plus big M G times, no, that's going to be MH. What am I doing? There, times, and this is all, this is MH there. That's all A, right? Times big M less than equal to mu S M G. Right? Here's the worst part. I've got to get this, I've got to solve this for MH. So assuming that everything on the bottom is non-zero, and they're masses, so they should be, and assuming everything on the bottom is not negative, well, they're masses, so they shouldn't be, I'm going to multiply both sides by mh plus m plus m. Right? Yay. So mh times big M times g is less than or equal to mu s mg times, holy smokes, mh plus m plus m. Boy, I don't like this anymore. This is no fun. But I'm still going to keep going because I love physics, even though the physics ended like 20 minutes ago. This is just algebra, and it's a mess of algebra. Why did you guys did you guys even do this for
Oh
homework?
yeah, I tried it. I took up 2 pages.
Really? Why? It's not so bad.
Yeah.
All right. I see two terms with MH in it, this one and this one. So I'm going to subtract and get MH capital MG minus mu S MG MH is less than or equal to mu S M squared G plus mu S M M. Wow. You guys paying attention, or is this just me now? Because this looks like it's from another planet. It's like gravity waves or something. Actually, it's not even close. This is like just algebra. It's just pain in the butt algebra. Bet you're wondering how this looked on the AP exam. They didn't ask for it. They hit it with a bullet instead. It's an easier problem. Well, I'm going to factor out the MH. I don't really have any space. Oh, I forgot there's a G right here. Shut up. So mu S M squared G. What's that?
Why don't you do it yourself?
It's here. It's when I distributed this G. Stop distracting me. Can I solve this for MH now and get an answer? All right, first, MH equals mu S M squared G plus mu S M M G all over mg minus mu S M G. Now, do you guys see that there's a G in every single term? So the answer doesn't have G in it. You could factor it out top and bottom and get rid of it, leaving you with this incredibly compact and super easy and easy to understand expression. Oops, I forgot it's an inequality. So here we go. Mu S times M squared plus M times big M all over M minus little m. Oh, mu S. I forgot the mu S. Mu S. Little m. Wow. 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 Let's see, that took us like, what, 25 minutes? Now, just to sweeten the pot here a little bit, look a little bit at this, if you don't mind. Because there's a minus sign here, and you know how I feel about minus signs, which means we have some conditions where there are no masses you can hang, and this will work, right? Also, MH has to be less than equal to this. It asks for the maximum. The maximum is when this is an inequality then. That's as big as it can be. There are some times where there's just nothing you can do, meaning it's going to win out, and that's why that negative sign in the denominator is a little troubling, because there's a potential to get a 0. However, mu is probably going to be a number less than 1. So as long as I don't put a really, really, really massive mass on top of the one that's on the bottom there, so as long as the little box is smaller than a big box, that's always going to be positive on the bottom there, and probably never 0. The top, though, has something interesting. I can pull this m out, and I get mu s times m. And I have this piece that's like inertia, the inertia for just the top. It's not accidental. You know, the inertia of the top dictates how the system moves. MH is part of that inertia too, which is why this is complicated. The problem that's on the AP exam fires a bullet into the top box, thus eliminating the actual part of the inertia of the hanging mass. Do you realize that by eliminating the hanging mass from all of this, this drops down to be a much simpler problem? But having the inertia of the hanging mass be a part of this problem is what makes this so complicated, because I have this group of three things that has to be dealt with, which is what makes the algebra just brutal. Let's say brutal question. Brutal question. And there's more to it, right? We didn't answer all of it. So if I want to answer all of it, number one, there are several forces acting on the foot. There's 40 newtons of weight. There is tension acting at 15 degrees. There is tension acting at unknown angle. And then there's the traction force acting this way. And we're hoping that this poor guy who's in a car accident has a net force of 0 acting on him, and he's not catapulted out of the bed. Hopefully. Hopefully the traction force pulls on the leg and there's enough friction acting on him between the bed and the leg to prevent the leg from dragging him out of the bed. Hopefully. Otherwise he gets catapulted out of the bed, like a cartoon character. Now, the thing is, that pulley system that you guys see in that picture there, so I'm thinking there's no great way to do this, so let's make this and this my x and y direction. Net force in the y direction is what I'm going to work on first. That's going to give me theta. So first I notice that there is two tensions here, with this one being 60 sine 15 degrees, and two tensions here, with this one being 60 sine unknown angle. Net force equals 0. So 60 sine theta minus 60 sine 15 minus 40 equals 0. Booyah. That's how you get theta. Do I have to do the algebra, or can you just tell me that sine theta equals some number, and that theta equals about 68 degrees? Right, Javon? Questions? So that was the y direction. If I take a look at the net force in the x direction, let's see, that's still got to be 0, so traction minus, I'm thinking 60 cosine 15 minus 60 cosine 68 degrees equals 0. You can do this one. This one's so bad. This one's all right. I don't feel bad about this one at all. There. Considering how the range of difficulties, this one's probably a little too simple for the AP exam, while number 8 might be too difficult for the AP exam. All right. This is the first. We're going to run out of time. This is number 1, FRQ. You should be more concerned about those FRQ problems, because those are actual FRQs from real AP exams. They are the real thing. That's the level of difficulty of your test. Meaning I will only give you problems that are off FRQs. That's what I've been doing. So we have a guy going down a ramp. And this guy is experiencing a drag force. So when you consider the skier on the ramp, he's experiencing a group of forces. Weight, normal force, and drag. And drag is equal to BV. That's the free body diagram to support the skier. You don't put a negative on your free body diagram. That was brought up in first or second period. The negative is simply to indicate that the force is in the opposite direction of the motion of the object. So if the velocity is positive, the force is negative. Now, the net force in the system has to equal ma. Assuming a coordinate system that is directed in the direction of the acceleration, then I would likely have mg sine theta down the ramp be what's pulling him down the ramp. I don't think I even care about mg cosine theta. I don't even think it comes up. So I'm going to consider the net force in the x direction to be the only thing that I care about. So I will have mg sine theta minus bv equals ma. You're supposed to create a differential equation. And I know you don't believe this, but we've talked about it. A is related to v. They're related in such a way that the first derivative of velocity is equal to acceleration. If I want to create a differential equation, I have to write this in terms of a differential that has a common variable, v. So I can write acceleration in terms of the derivative of v. So my differential equation will be mg sine theta minus bv equals m dv dt. This is a differential equation that when solved would give me v as a function of time. That's as far as you have to go. Yes, sir.
So, in the problem system I did, it starts all algebraic answers from...
That's question D. That's not what question B asks. Question B asks for you merely to provide the differential equation that when solved would give you velocity as a function of time. They separate this out because, as I said to you guys before, you can get a 4 on the exam if you can't do calculus. This is not calculus. I expect this from all of you, even if you don't have calculus. But since we all have calculus, you will learn how to solve this. That's question D. I forgave you if you didn't do question D. Now, I'm not done, but what question do you have about what I just did? Yes, sir?
Could you do Galileo's motion equations?
No. Galileo's motion equations assume the acceleration is constant. Is this acceleration constant?
No.
No. Please don't make that mistake, because that mistake will cost you all the points of this problem. Do you understand? The most likely place that you will always construct a derivative is either going to be from analyzing energy or analyzing force, because energy often has position and velocity, right? Height and v, and force often has velocity and acceleration. That's where you're going to get your differential equations. So, question C says, what's the terminal velocity? You did this, lab. If you got this wrong, I am mad at you. Because the terminal velocity occurs when the net force equals 0, which means when the acceleration goes to 0, you're at the terminal velocity, which means mg sine theta minus bv equals 0, terminal velocity. You're no longer accelerating. Put the little t there. So mg sine theta over b equals vt. It was that simple. Yeah, I expect you to be able to do that. In fact, it says plot a function of the acceleration as a function of time. I thought it was velocity. Acceleration's even easier. This is time. This is acceleration. I know that at time equals 0, mg sine theta minus bv equals ma. At time equals 0, v equals 0. So at time equals 0, the acceleration is equal to g sine theta at t equals 0. So your graph should have a starting point. Without it labeled, it is wrong. And you basically have three choices as to what to do next. Except for the foolish people who I know out there had something like that. I don't know what the frick you're doing. Or even the people who have this. What? Listen, is the acceleration going to get greater or smaller? Acceleration is going to get smaller. So you've got, I think, three options. You've got, those are your three options. Pick one. You got a 33% chance of getting it right. Anybody who shows the acceleration getting greater loses. Now, ask yourself, in the long term, is the velocity ever going to reach terminal? I want you to think about this relationship. The velocity gets bigger, so the acceleration gets smaller. Eventually going to reach a point where you're going to have to wait a really long time because the acceleration is so small it can barely change the velocity. But the velocity is getting closer and closer to the terminal velocity, which is where the acceleration will be 0, suggesting that only one of those makes the most sense. Which is why I would have preferred they ask you what the velocity is, and they do. I just apparently clipped that graph off. But velocity versus time has to approach vt. That's the velocity as a function of time. Starts at 0 and approaches the terminal velocity. Pretty. Now, let's handle this for all of you. I don't for a moment want to think that I can let you off the hook, but you are of limited mathematics right now. We will not be able to throw away questions like question D for very much longer, but you guys have not even learned how to do integrals yet. So I can't likely expect you to be able to do this. I am going to tell you that there's part of this I do expect you to do. You should be able to set up the integral. That has nothing to do with calculus. It's procedural. And we've talked about this already, a little bit. It's called splitting the differential. If you want to solve this, you have to split the differential. The following steps I expect you to do. Splitting the differential begins by doing exactly what it sounds like, multiplying both sides by dt. That splits the differential up and gives me mg sine theta minus bv all times dt. The other side of the equation is just going to be m dv. The reason we do this is we can integrate both sides of an equation. Meaning I can apply the integral to both sides, which will give me an expression over here in terms of v and an expression over here in terms of t. Thus, I can solve for v and get v as a function of t. The problem is you can't do the integration. So you're kind of stuck. But actually, you would not get full credit from me if this is all you do. Because the only way this works is if everything in here is completely unrelated to this. Do any of those variables change as time goes on? Velocity. I can't leave it there. I can't have anything on this side without substituting in a relationship for it in terms of t. However, I note that v is on this side. So I'm going to want to get that over to the other side, which means I got to divide both sides by that expression so that each side of the equation only has things on it related to the variable that our derivative has. Now, this is just algebra, and yes, you can do algebra. Now, to go to the next step where the answer will be right here, That's calculus. And you need use substitution to do this, and you guys don't have it yet. In fact, you don't even have integral yet. So I'll leave that part till later. It's going to involve one of those natural logs and stuff like that. And if your logarithm skills are weak, get ready to strengthen them. All right, bye. This has been a lot of fun. Did I make you